Hello everyone, my name is Nandita Mohanta, Assistant Professor of Civil Engineering Department. Today I will discuss about Introduction of Geotechnical Engineering. Why it is important in civil engineering. So, if we design a very good structure, very economic structure, it may be lightweight or heavyweight, all structures are resting on ground. The weight of structure is taken by soil. So, even though we design a very good structure, but soil present below the structure, if it is not good, then structure may collapse because of large settlement of our structure. So we should understand that what is happening in soil. If a structure is constructed, what is the properties of soil, what is bearing capacity of soil, how much load can bear the soil, everything we will study in geotechnical engineering. So let's start with definition of geotechnical engineering. Geotechnical engineering is the study of the behavior of soil under influence of loading, forces and soil water interactions. This knowledge is applied to design of foundations, retaining walls, earth dams. So here geotechnical engineering deals with how soil behave when subjected to loads and how water in soil affects that behavior. This is essential in safe design of foundations, retaining walls, dams. We can also say it is the backbone of civil engineering when building anything on or in ground. So next is introduction to soil. As per civil engineering, soil may be defined as an uncemented gathering of mineral particles which are produced by disintegration of rocks. So here soil is formed by disintegration of rocks, means weathering. Weathering is two types, physical weathering and chemical weathering. So by physical weathering, coarse grained soil are formed like sand and gravel, and by chemical weathering, clay formed. So next is scope of geotechnical engineering. So geotechnical engineering has very large application in construction of various civil engineering works. The physical properties of soil mechanics is particularly helpful in following problems of civil engineering like foundation design, construction, retaining structures, underground structures, stability of slopes, pavement design and design of earth dams. So here geotechnical engineering is widely used in designing foundation for structures, retaining walls to hold back soil, and planning underground structure like tunnel, designing pavements and road structures, constructing safe and stable earth dams. It helps a civil engineer to understand soil behavior and select the right construction method. So next is foundation design and construction. Every structure every structure weight to ground. Foundation is an element of all civil engineering structures. Every structure like building, bridge, dam, highway, tunnel, canal is founded in or on the surface of the earth. Foundation are transmitting loads of structure to soil safely. So here every structure transfer weight to ground. So foundation depends upon soil type, load and groundwater. So there are many two types of foundation like shallow foundation and deep foundation. As per the load condition and soil type, we will decide type of foundation. So next is so here we can see this lower part of structure is called foundation. These are contact point between structure and the soil. This type of foundation depends upon load, soil properties and groundwater presence. So here foundation must safely distribute the load to prevent settlement or collapse. Next is retaining structure. The structure which retains large mass of earth on its side is called retaining structures. This theory of earth pressure given by geotechnical engineering is required to design such retaining structures. So here retaining structure hold back earth like hilly roads or basements. So this image we can see the gravity walls or cantilever walls. This image visualize how this structure supported soil mass. So theory of earth pressure is given by geotechnical engineering is required to design such retaining structures. So next is underground structures. It consists tunnels, pipelines, underground buildings are subjected to various forces exerted by soil mass. A knowledge of structure interaction is essential to design properly such structures subjected to soil loading. So here we can see underground structures. So here tunnels and pipelines are beneath the surface. These emphasize the need of geotechnical engineering during design because these structures are exerted by soil. So next is stability of slope. When surface of structure is not horizontal, in such case of highway embankment or irrigation canal, the component of gravity tire to move soil downward. So gravity tend to pull soil downhill. So a complete knowledge of shear strength related to properties of soil is necessary to design the slope of embankment or excavation. So engineers use shear strength to design stable and avoid landslide or erosion. Next is So here we can see this image showing a sloped surface with forces acting on it. Next is pavement design. A pavement can either be flexible or rigid. Its performance depends upon subsoil on which it rests. So, soil must have good strength and stability. If the soil below the pavement is weak, then we need to improvement before road construction. So this image is showing cross-section of rigid and flexible pavement. These are pavements like pavements layer. These are pavements layer, past layer, surface dressing, surface course. This is flexible pavement. Base course, concrete slab is here. This is rigid pavement. Okay. So at last we can see this is natural soil below the pavement, and these all layers distribute the load to soil. Next is design of earth dams. Earth dams are massive soil structures and storing water. This needs deep knowledge of to design earth dams. Deep knowledge of civil engineering, deep knowledge of geotechnical engineering is needed, like soil properties like density, plasticity, permeability, and compaction characteristics. So here proper investigation is very important before dam construction. If dam is got failure, then it can lead widespread disaster. So therefore extreme care is taken in its design and construction. So here image showing a dam body with core cells and seepage control measures. Next is limitations of geotechnical engineering. Also, as the soil at every location is different, the experience from the one project cannot be directly applied to other project. The strength and behavior of soil depends upon pressure, drainage, climate conditions, and many other factors. So here every site has different soil. Experience from one place to other place cannot be copied exactly, because soil behavior varies with pressure, drainage, climate, and depth. So this makes prediction difficult. So this makes prediction difficult and requires site specific studies. Okay, site specific studies are required because soil behavior are not same. So these are limitations of geotechnical engineering. So next is fundamental use of soil. In civil engineering, soil has two fundamental uses, as a construction material or as a foundation. So as a construction material, we will use in highway embankment, railway embankment, earthen dam, filling in low-lying areas. Suppose we want to uh, we want to we want to ground level up, then we can use soil as a filling material. Okay, so as foundation, building, bridge, highway, tunnels, canal, dam, these are the examples. So next is soil formation. Soil formation is process by which soil is created. The formation of soil happens over a very long period of time. Soil is formed from weathering of rocks and minerals. So here soil is formed by weathering of rocks, and weathering is two types. First is geotechnical engineering, second is physical weathering, and second is chemical weathering. So in physical weathering involves breakdown of rocks and soil through direct contact with atmospheric conditions such as heat, water, ice and pressure. This is without any change in chemical conditions. Like by physical weathering, we can find coarse grained soil like gravel and sand. So here by day sand and gravel are formed by physical weathering. Because of daily and seasonal temperature changes and flowing water, glacier and wind, which produced impact and abrasive action on rock. And next is splitting action of ice, growth of root of plants in rock fissures. All these are cause of physical weathering. So next is chemical weathering. Chemical weathering is caused by rainwater reacting with mineral grains in rocks to form new mineral and soluble salt. These reactions occurs particularly when the water is slightly acidic. The decomposition of rock is the result of following reactions like oxidation, carbonation, hydration and leaching. So here chemical weathering involves the reaction between rainwater and rock minerals. It produces clay minerals and soluble salt. So here oxidation, carbonation, hydration and leaching, these are the cause of chemical weathering. So oxidation means oxygen in air or water reacts with rocks. Okay, so and carbonation is rainwater forming a weak acid called carbonic acid, which is reacts with minerals of rock. That is also cause of chemical weathering. Hydration, water molecules combine chemically with minerals of rocks. Okay, so this is also chemical weathering. And next is leaching. Leaching is process by which water dissolves and carries away minerals and nutrients from soil or rocks. Okay, so by these But these are the main cause of chemical weathering. This is all about first chapter of geotechnical engineering. Okay, so thank you.